I'm so glad you came today. Today I have some really fun stuff for us to do together. So are you ready to get started? Okay, so today we're actually going to talk about states of matter. And then we're going to talk about something that doesn't follow the usual rules. But first, let's think about water. How many different states do you think that water exists in? So a state is like, is it a liquid? Is it a gas? Is it a solid? Is it a plasma? Plasmas are really rare, and I'll give you a hint. Water is usually wet. So let's talk about water. Water, when it's at room temperature, is a liquid. A liquid is something that maintains its volume. So its volume always stays the same. That always means there's the same amount of it unless you add more to it, and it takes the shape of its container. So if I pour it from this shape into this shape, it's going to change. The amount of water that there is hasn't changed. Now, water can also be a solid. This is a solid. What's the difference between this water and this water? Well, it's colder, so I hope you said that. But the other difference is this one holds its own shape. It doesn't change its shape based on the shape of the cup. It keeps its own shape. Do you see how that works? Now, the last one that we're going to talk about that water can be is actually a gas. So when water gets really hot, or sometimes just because in the air, it will evaporate or it will turn into water vapor, and then it turns into a gas. But we can't see it around us because it's just in the air. So to show you what a gas does, so a gas, its volume depends on the container. So there's the same amount of air in here right now as when I go like this. There's just always the same amount of air in there. But watch this. I'm gonna go. What just happened? I didn't crush it with my hand. Watch again. What did I do? So I sucked the air out into my body. And when that happened, the shape of the container changed because there wasn't any more air in there to keep it in the same shape. Now I can also do the opposite and blow it up. And when I do that, that means it's all filled up with air again. And air is a gas. Now for the last thing we're going to talk about with water, I'm going to boil some water for you so you can see some of that water vapor coming out. And it's even going to make a cool noise because I'm going to boil it in my kettle. So it's going to build up so much pressure inside my tea kettle that it's going to shoot out and make a whistling noise. You want to see? Okay.
Now here I have my kettle, and it's been going for a little bit. You can see the steam starting to come out of its spout. And then once it really builds up a head of steam, it's going to go ahead and start to whistle. So it's really starting to come out now. Do you see that? That's the water vapor. When we added heat to the water, it makes it become a gas. And the gas is building up inside, and then it'll start to whistle in just a minute. So the last thing we're going to do is create a non-Newtonian fluid. And what that is, it's a fluid that sometimes acts like a liquid and sometimes acts like a solid when it's at the same temperature. So to make this, you're going to need some cornstarch and some regular water. You're going to want to add about twice as much cornstarch as water. And then when you mix it, it should come together and be pretty hard to stir. But the really interesting part comes when you try it, because you can pour it and you can break it. So sometimes it acts like a solid and sometimes it acts like a liquid. So we're going to see what Henry thinks of this. So I've prepared that. Now watch what happens when I pour it into a bowl. It's going to pour like a liquid. But then I'm going to grab some while it's pouring, and you'll see what I mean, how it breaks up like a solid when you grab it. So a non-Newtonian liquid, this one in particular, is reacting to pressure. So when it's just under a normal amount of pressure, it just pours like a liquid. But as soon as I start to squish it, it'll start to act like a solid and start to break apart and crumble. But if I let go, it turns back into a solid. So let's see what Henry thinks of this when I show it to him.
Henry, what do you think that is?
I'm not sure.
But do you think it's a solid or a liquid?
I think it's a liquid.
You think it's a liquid? Now push it with your fingers. No, 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 no.
Oh.
Push it with your fingers. Reach in and push it with your fingers. Is your finger going in? Now pull your finger out. Now push it in hard.
How is it doing? Oh no, it's done! It's like liquid solid. When I put my fingers in, it's a liquid. But it looks like what?
You want to try, babes?
No. I'm gonna be stuck, Alice. Help! My fingers are stuck.
Can you pick it up like a solid? Okay, now flip your hands over and let it go.
Oh,
Now
I
just
can't.
now just be still. What happens?
Oh no! I get off me. This is the most disobedient liquid I've ever had.
Disobedient liquid. That's a great. It's called a non-Newtonian liquid.
You're so disobedient. Get off!
I know, Henry. It's what's called a non-Newtonian fluid.
What's a non-Newtonian?
So
fluid?
a Newtonian fluid follows the rules. Like it's either a liquid or a solid or a gas, right?
This is like both liquid and solid, but it's not gas.
So what makes the difference between it being a liquid and a solid, do you think?
What?
Why do you think when is it behaving like a solid and when does it behave like a liquid?
When it behaves like a liquid is when you leave it still.
When you leave it still, and when does it behave like a solid?
It's when you fiddle with it.
And you when you put pressure on it, right? So
and
when
this
you
thing
put
won't come off.
I know, we'll wash it in a minute. So when you put pressure on it, it turns into a solid.
It's like I have to get. I get up.
Wasn't that super cool that there was something that kind of broke the normal rules? And wasn't it cool that we could learn that we had energy as heat to change things, or we can take energy as heat away to make things into a solid? Pretty much anything's state can be changed. Think about some of the foods that we sometimes melt, like chocolate or ice cream. Those are all changing state. Ice cream actually changes its state usually in your stomach or in your mouth, because your mouth and your stomach is warmer than the ice cream. So it actually turns from a solid into a liquid inside of you. Well, I'm so glad you came. I hope you had a great time. I know I did. Bye.